Today I'm going to be teaching you about spherical mirrors. So let's go into some equations and some notes to consider. So the mirror equation is this. It is 1 over f is equals to 1 over do plus 1 over di. So what are they? So this f is the foci. Oops, this is big. Let's make this smaller. Here. So this little f here is just considered as foci. So I'm going to draw some diagrams later, but I'm not going to focus on them. I will focus it on other video. We're going to focus on solving problems involving these equations and considering the tips we have on the right side. So this d sub o is just the distance of the object, and this d sub I is going to be the distance of the image. Okay, I need a space. So distance of the image. So here, this is r, or sometimes considered as c. It is just the radius of curvature. So this 2f is just twice the foci. So this m here, magnification equation. So this is very important equation. I mean, all of these are important. So this just new. This di over do is not new, but this hi over ho is new, right? So ho is just the height of the object, and this hi is going to be height of the image. So yeah. So we have here tips or notes. So if the concave mirror is, if it's a concave mirror, therefore the foci is positive. If it is a convex mirror, we will put a negative sign in our equation. So I'm going to put this thing. I'm going to highlight. So now, if d sub I is equals to positive, then it is a real image. If d sub O is negative, it's going to be virtual. And the absolute value of magnification is greater than 1, then it's enlarged image. Absolute value of m is less than 1, it is reduced image. If it's the magnification is negative, then inverted image. And if it's positive, upright image. Now let's consider this practice problem. A 5 cm tall toy is placed 20 cm in front of a concave mirror that has a radius of curvature of 30 cm. So as we can see here on below of the problem, we have questions, and also I did some illustration to illustrate this problem. So in this thing, this will be the height of the image. So I'm gonna write this. This is going to be the height of the image where the two rays just intersect each other. Now let's move on to part A. Where's the image located? So we're just going to use the mirror equation formula. So it's just 1 over f. We're not going to put a negative sign to our equation. Okay, so let's calculate the radius of curvature first. I mean the foci. Because we have a given here that is radius of curvature, but we doesn't have a foci. So the radius of curvature is 30 cm, and this is just 2f. Dividing both sides, we got 15 cm as our foci. So as we can see in our diagram, foci is just between the object and the concave mirror itself. Okay, I forgot to change this as question mark. Okay, here. I'm trying to be perfect in my sentence. So we're not going to put a negative sign to our mirror equation because we are on a concave mirror. So now we're just going to plug in values and do some algebra. So the foci is just 15 cm, and the distance of the object, that is what we're going to calculate. I mean the distance of the image we're going to calculate. Whoa, did I miss my... Okay, I'm kind of sleepy though, but it's fine. So now 15, and then So now what we're going to do is just distribute this thing. Okay. So what we will get here is just 20 di. 20 will cancel, so we will get 15 di. And then di will cancel here, so we will get 20 times 15, which is, how many is that? 20 times 2 times 15 is 30, so just add those zeros and then we get 300. So now let me delete this. So what we're going to do is just transpose 15 di to the left side, so we'll get 5 di. Then we have 300. So dividing both sides, we will get the distance of the image is going to be 60 centimeter. So that's basically it. That's the distance of the image. It is located 60 centimeter from concave mirror. Okay, now, is it real or virtual? So to consider this, we're going to know if the distance of the image is positive. So the distance of the image is positive, therefore it is real. So as di is equals to positive. So is the image upright or inverted? What we need to calculate here is the magnification. And then if it is positive, then it is upright. If it's negative, then it's... Okay, let's just plug in things here. So di is going to be negative 60 because we have a negative in our equation. We could just cancel zeros and we will get negative 3. Therefore, the magnification is negative. Then it is inverted. So as we can see in the diagram, it's really inverted, right? Okay, now let's calculate the magnification. Oh, we already calculate the magnification. So the magnification is just negative 3. So what is the height of the image? So as we have the magnification, we can just basically calculate the height. So this is going to be negative 3, height of the image over height of the object. So height of the object is 5 centimeter. So just going to be negative 15. So it is negative because, you know, it's just inverted image. So that's negative 15 centimeter. But in the law of physics, it is a scalar quantity. Therefore, height is always positive. We're just putting some negative sign here to indicate that it is inverted image. Now, let's go to F. Is the image enlarged or reduced in size? So to know that, we're just going to get if the absolute value of M is just, what do we do here? Less than or greater than to 1. So this is wrong. It is actually greater, right? So the magnification is greater than 1, therefore it is basically enlarged image. And that's basically it for this problem. Now let's move on to other one. Now let's do this. So we're just going to plug in every formula here. You can pause the video and read the problem because, you know, I'm just plugging in things. So what we're going to find here is just the distance of the image. We already know how to calculate this thing and how this works. So you can just basically do it. How many times did I say basically? So this is just going to be this and this is going to be this. Now we can just move it to the left side, so we'll get negative 10 di and then 200. So di is going to be negative 20. Okay, so this is the distance of the image. So if you're going to look to our diagram, it is very different than the other one because the foci is on the left side of the object, which is pretty much farther than the concave mirror, right? So you can just analyze things here. So is it real or virtual image? So this is basically virtual image because it is negative. The distance of the object is not actually the distance of the object, but the distance of the image is negative. Now let's calculate the magnification. So we got 2, positive 2 as our magnification. So is the image upright or inverted? So as we can see, our magnification is positive, therefore it's just upright. And we can also see it in the diagram. It's on the right side of the... It passed through the concave mirror, meaning it is just upright. So we can just also see if it is enlarged or reduced. It is enlarged. So what is the height of the image that we're missing? So we can just basically use the formula once again in order to do that. So it is enlarged because it is greater than 1. Okay, now, so we got this. Then HO on the bottom, it is 8. So cross multiplying, we will get 16 centimeters. So this is the height of the image. It is much bigger than the object itself. So now let's move on to our last problem. Okay, so JD finds a convex mirror to stand in front of. She sees her image reflected 7 feet behind the mirror, which has a focal length of 11 feet. Her image is 1 foot tall. Where is she standing and how tall is she? So we're going to calculate her height and her distance on the convex mirror. So we're just going to put some calculation here. Don't forget that our distance image is just -7. It's not going to be positive. So doing some algebra here. So we did some algebra. You can just pause the video and replay this and try this out yourself. We actually put a negative sign to our equation because this is a convex mirror. So her distance is 19.75 feet from the mirror by doing some calculation. Okay, now let's calculate JD's height. So on the mirror, she looks like 1 feet. Wow, she's very small. So what is her real height? Okay, how can we do that? So first of all, we're going to calculate the magnification of this thing. So the magnification, in order to do that, we're going to use it twice. The first one is by this formula. So magnification is going to be equals to negative. So we got -7 distance of the image. And then distance of the object we calculated earlier. So it's just 19.25. And then dividing this thing, we will get 0.36 repeating. So this is the magnification. So this is reduced because it is less than 1. So now we're going to use this again, this formula once again, but we're going to put different things. So 1 there is just 1 feet height of the image. Cross multiplying, we will get this. Now we're going to divide both sides. So height of the object or height of JD is going to become 2.75 feet. So she's still pretty small. But I think she's a kiddo. Okay, that's it for this problem and this video. I hope you learned something. And that's basically it for spherical mirrors. Goodbye.